Welcome to our second lesson on the introduction to combining like terms, and this is part two. You should already have this on your paper, and hopefully you watched the lesson before this. So let's review. Like terms are terms that have the same variable raised to the same power. So for instance, this is an x term and this is an x term, but this one is raised to the second power. We also call this x squared. So 6x squared and 2x squared have the same variable raised to the same power, so they're like terms. 7x, 3x, and 1x are also like terms, but they are different from x squared. And just as a reminder, when you have a variable that's by itself, we can put a 1 in front of it because 1 times x or 1 times anything would be that same number. And since we don't know what x is, we're just going to call that 1 times x. These two do not have a variable, and they have a special name. They're called constants. They're exactly 9 and exactly 5, and they're not going to vary in their value. So now that we have this, we're going to try to combine the like terms. We've gathered them up, but now what we want to do is we want to put them together. And when you hear the word combine, I hope you think about the word adding. We're going to add their coefficients. So for this one, I'm going to look at 6 and look at 2. So we're going to add those two numbers, and we're going to get 8, but they're x squared terms. So I like to think about this as being 6 of the x squareds and 2 more of these x squareds, leaving us with 8x squared. So the next group of like terms, we're going to take their coefficients and we're going to add them. So the 7 plus 3 plus 1, and they're all x terms. So we have 11x. And then finally, the constants, because they are just plain numbers, we are going to go ahead and add their values, and they add up to 14. So if we wanted to create an expression out of this, we would just put plus signs, and now we have a trinomial. 1, 2, 3 terms when we started out with 7 terms. So that's why we sometimes refer to this as simplifying expressions. So now let's go on to the next example. So if you watched our last lesson, when we have two different variables, we start with a variable that comes first in the alphabet. So that's why we gathered up x's first, then the y's, then z, and the constants come last. And using what we did last time, we want to gather up, combine our constants, so we now have 14x. The next group of like terms, we have a 3 and a 1, so we're going to combine, and we get 4y. And that's why it's very important for us to write the 1 in front of the y. However, when we look at this, we just have one z, so most of the time we choose to just write this as z. However, if you put 1z, that's perfectly correct. And then we're going to combine our constant of 8 and constant of 4, and that leaves 12. Now, because it didn't start out as an expression, we don't have to do this. However, if we wanted to make an expression out of it, we would just go ahead and put plus signs. So now we've again taken terms that are 7 terms, and we're able to simplify them down to 4. So if you completed part 1, you should have 5x squared on this line, 3x and 9x on this line. They're like terms. And we had 4 constants. The constants, whether they're positive or negative, are the same. Would you please tell me what the final expression should look like? So if you combine all the like terms, you'll have 5x squared. Since it's a positive 12, we'll put a plus, or positive 12x. And since it's a positive 26, we'll make that a plus 26. Please turn to the back page now. All right, these are the terms that you should have. You should have gathered up the x squared terms, the x terms, and the constants. what is the answer when you combine these two terms? If you said negative 1x squared, you're correct. In fact, the high school way to write this is just negative x squared. Please tell me what this next group would be, what it would look like after you combine the like terms. If you gathered them up and you said 10x, that is correct. And last but not least, would you please tell me what happens when we combine these constants? And that would be positive 3. Again, if we wanted to make an expression, we could simply put plus signs in between here. So we just took 8 separate terms and we're able to whittle it down or make it into smaller or simplified, as we would say, into 3 terms. Let's move on to letter E. So we've gathered up our A's terms, we've gathered up our B terms, our C terms, and our constants. Please tell me what you think the first group would be when you combine it. What would the final A term look like? The correct answer is 1A. Again, in high school, they would just show A. Let's go on to the B terms, combine all the B terms. If we add 9 plus negative 8, we get 1 plus negative 3 would be negative 2. Now let's go on, and would you please take care of the C terms and the 2 constants. Altogether, if I added the coefficients from all of the C terms, we would get 7. And 6 plus 8 is 14. So now let's move on to our final problem, which is letter F. This particular problem is a little bit more complex. This time we not only had x squared x, they also included x to the 3rd power. And x squared is a nickname for x raised to the 2nd power. And x to the 3rd power we sometimes refer to as, with this little 3, we refer to it as x cubed. So that aside, from the very beginning it said you always start with the highest powers. So we're going to gather up, and we're going to look at where the highest powers are. I see 2, I don't see a power here, which is an implied 1, and I see 3 as I scan the problem. Oh, there's another term that's raised to the power of 3. So we're going to write this as 6x to the 3rd power, and then we're going to gather the other term that has x to the 3rd power, which is negative 9x to the 3rd power. So I don't see any other terms that have x raised to the 3rd power. Now we're going to gather up x to the 2nd power, and I see a few of those. So we're going to start with x negative 4x to the 2nd power, or negative 4x squared, and negative 2x to the 2nd power, also pronounced as negative 2x squared. And last but not least, we're going to go for the terms that are just x without an exponent. So our first one is negative 3x, the second is 8x, and the third is negative 5x. So now I'd like you to combine the terms for our very first group of like terms. If you said the answer was negative 3x to the 3rd power, you're correct, because the coefficient was 6. The coefficient of this one was negative 9, and when we add unlike signs or different signs, we actually subtract and keep the sign of the highest value. Go on to the x squared terms. This should have been negative 6x squared, or we can pronounce it negative 6x to the 2nd power. And if you recall, when we have a negative and we're adding another negative, in other words, same signs, we add them and keep the sign. Please tell me what the last set of like terms would be when we combine them. This was a little bit tricky. When we say negative 3 plus 8, we're going to subtract their different signs, and we'd have positive 5. positive 5 plus negative 5. Those are additive inverses, which bring us back to 0, and we have 0x. Now, we would prefer, if we're going to write this as an expression, we would want to keep the negative 3x to the third power, and we'd want to keep the negative 6x squared. However, since this is 0, we probably would not need to write it. However, I appreciate the fact that you're showing it so that we know what the answer is. However, when we're truly simplifying, we prefer not to show anything that's 0. There's 0 x's, therefore we wouldn't need to show it. Thank you for listening, and we'll try this again tomorrow.